we will see that we have to specify before using those port, any of the port, whether it is being used as an input port or output. Okay, I will come to the ports after some time. So there are 4 ports, and each port has got 8 pin, and so if 32 pins are occupied by these ports, so remaining are 8 pins. So let's see what are these 8 pins. And there is another important feature of microcontroller, which is also there in microprocessor also, which is called multiplexing. What is mean by multiplexing? Multiplexing basically refers to a situation in which you have got pin which perform more than one function. Okay, so same pin. Let me take this example of this pin number 13, also referred to as port 3.3, the third pin of port 3. And if I go by number, it is the 13th pin. And you could see that INT1 is written along with P3.3. So P3.3 is an IO port, also pin of an IO port. Okay, so one function of it. The second function is that this pin can be used for external hardware interrupt also. So this particular pin 13, is basically can basically act as a IO port also, and it can act as interrupt pin also, and definitely not both at the same time. So they will act as an IO port or as an interrupt pin, depending on again the programming condition, what you program them. Okay, so multiplexing basically refers to a condition in which a single pin is used for more than one application. It could be 2 or even 3. Okay, although in 8051 you have only 2 function at a time at most, but each of these function can happen uh, uh, in isolation. That means one function can take place at one time. Okay, so I hope you understand what is multiplexing. Now let us turn our attention to some of the other pins and some of the multiplex pins also, and we will discuss each one of them one by one. So let's start with these 2 pins, pin number 18 and 19, XTAL1 and XTAL2. XTAL1 and XTAL2. So these pins are basically connected to a crystal oscillator. It is connected to a crystal oscillator, and the frequency of that crystal oscillator is 12 megahertz. You see, microcontroller, it works when it receives clock signal. Okay, and each of the step that is executed in a microcontroller, it happens when it receives a pulse, and that pulse is generated from a crystal oscillator that is connected to these 2 pins. Okay, and it normally operate at 12 megahertz. That means the operation frequency in 8051 is happening at 12 megahertz. Although some of the operation is at much lower frequency, and it is 1 megahertz, it gets divided by 12, and I will tell you in further lectures why it happens. But right now, just remember that we give pulses of 12 megahertz from these two pins XTAL1, XTAL2 to the microcontroller 8051. And in some situation, we even give pulses of frequency 8.0592 megahertz. So why this peculiar type of frequency is given? And it is given when we are using 8051 for serial communication. So it has something to do with baud rate, which we will discuss when we will be dealing with the serial port and serial communication through 8051. So you have to remember that we use both 12 megahertz as well as 11.0592 megahertz frequency crystal oscillator for 8051. Okay. Now let's move forward and take up another pin, the pin number 9, which is RST or reset pin. So the second pin is RST, and it is basically the reset, sorry, the reset pin. So as the name refers, reset means what is going to happen. So 8051 has got RAM as well as ROM, and I told in the previous lecture that RAM is to store data and ROM is to store program. RAM is volatile memory, ROM is permanent memory. So when you reset the 8051 microcontroller, all the things that are stored in RAM gets erased, they vanish. Okay, but the things that are in ROM, which is program, it remains. So RAM is reset, and there is a SFR, special function register, called program counter, and it becomes 0000H. Its value becomes 0000H. So what is program counter? Why its value changes to 000H when we reset it? We will talk about it when we will discussing. When we will discuss program counter. Okay, we will have a separate lecture on program counter. It is a important SFR. But right now, since we are discussing only the pin, so I will just be telling you some important details of the pin only. Won't be going into the detail of each of the pin. And this location is also called the reset vector address. Reset vector address. Okay. And what happens when reset button is set? Then there is a program called BIOS. BIOS. BIOS, which is actually a booting program, and it is executed once reset button is set. Okay, so reset button, it executes BIOS program. It is also called booting program or sometimes monitor program. Okay, now let's move to another pin, which is your ALE. Let's see what's its position. You see ALE pin. ALE pin is here. Separate pin, ALE. Okay, it is also multiplexed with another function, program bar. I will talk about it later. Right now, ALE pin. So ALE refers to address latch enable. Address latch enable. Okay. So Let us see what's its function. So it is used to enable the latching of the address. And what happens? The address bus and the data bus in 8051 are multiplexed. Okay, and this is done to reduce the number of pins that are required by the 8051 IC. Okay, so just see the pin diagram once again. So you could see we have pins of port 0, which are referred to as AD0, AD1s, and AD7. And then we have pins in port 2, which start from AD8 to AD15. Okay, so the lower half pins, that is A0 to A7. So we have pins from, sorry, A0 to A15. These are uh, address bus pins. Okay, and they could be divided into this. We have higher bit pins, and these are lower bit pins, A0 to A7. Okay, these lower pins are multiplexed with the uh, data pins D0 to D7. That means the pins could be carrying the address or it could be carrying the data. But as I told you, that it can happen one at a time. So pins are multiplexed. They could be carrying address or they could be carrying data depending on the value of ALE, address latch enable. Okay. So uh, if ALE has got a value 1, then the microcontroller is transmitting the address or A7 to A0 through pin of port 0. Okay, they are in port 0. So and when ALE is equal to 0, then data is being either going out from the the microcontroller, it is being received by the microcontroller. Okay, so definitely both do not happen at the same time. It happens one at a time. Again, this would be much clear when we would be uh, doing some programming. And I should tell you here that address bus and data bus, uh, they are normally required when we are doing programming with external RAM and ROM. External ROM. Okay. So in that case, we require to send the address data. Okay. Anyway, we will come to this when we will do some programming. Right now, you understand that when ALE has got value 1, that means the thing that it is carrying in the pins is the address. And when ALE is 0, the thing which is carrying in the on the pins, in the port 0 pins, port 0 pins, is the data. Okay, fine. Let's move to another important pin, which is EA bar. EA bar. Okay, here you could see the pin number 31. EA bar. EA bar. So it is enable external access. Enable external access. Okay, so what it imply? So it implies that I told you that 8051 has got internal RAM and ROM. Okay, and we can connect external RAM and ROM also to 8051. Okay, external RAM and ROM. How much? 64 kilobytes of RAM and 64 kilobytes of ROM can be connected to 8051. How I arrived at this number? Because the size of the address bus is, there are 16 bits, 2 to the power 16 addresses can be uh, identified. 2 to the power 16 is nothing but 64 kb. Okay, exactly speaking it is something 65,000 something number, but we refer to as 64 kb, 64,000 bytes. Okay, so that means I can address 64 or access 64 kilobytes of RAM and 64 kilobytes of ROM. Can I do it both at the same time? Uh, the obvious answer, which looks like, is no, because since we have got 2 to the power 16 uh, uh, address locations which could be accessed by 8051, we cannot use 64 kb of RAM and 64 kb of ROM at the same time, because they add up to 128 kb memory space. So that would definitely require one more 2 here, okay, for accessing this much of memory uh, address. But I will tell you there is one pin which is called PSEN. I will come to that. This helps in actually accessing 64 kb of RAM and 64 kb of ROM at the same time. Okay, so at the same time, we can connect 64 kb of RAM and 64 kb of ROM to 8051. Although the length of the address bus is 2 to the power 16. And how it is possible, I will tell you when I discuss PSEN. Okay, right now I was discussing EA bar, enable external access. So I told you that there are 128 bytes of RAM and 4 kilobytes of ROM as internal memory in 8051. So accessing external RAM is not an issue, because we have got separate instructions for internal as well as external RAM. And when I will discuss, I will tell you that we have got move command for internal and move X for external RAM. So they do not have a problem. But when it comes to ROM, there is an issue. And issue is whether we are when we are talking about the address of ROM, whether we are talking about internal ROM or we are talking about external ROM. So that is identified by this EA bar. So if it is 0, that means we are discarding the internal ROM. We are discarding the internal ROM, and we are using only the external ROM. Okay, 64 kb ROM, external ROM, sorry, external ROM. And when it is 1, then we are using both internal ROM as well as external ROM. And we access both of them. So that means address from 00 till 4 KB is reserved for internal ROM, and address above that is reserved for the external ROM. Okay. Okay. So let's move to some other pins. So we have got this ground and VCC. So VCC is connected to plus 5 volts and ground is grounded. Okay. These two pins are connected to one 5-volt power supply, and other is grounded. Uh, then let's talk about the various ports, various IO ports. So first talk about the unmultiplexed, which is P1 port. You see, none of the pins of P1 are multiplexed. Okay. So the ports, I told you there are 4 ports and each with 8 pins, and port 1 is not multiplexed. It is not multiplexed. Okay. Now uh, one important thing about these ports is that they all are bit addressable. Bit addressable. What is mean by bit addressing? So let me explain it. What is bit addressing? So we can access each of the pins of the 4 ports. So if I am talking about port 1, then P1.0 refers to pin 0 of port 1. Pin 1.1 refers to pin 1 of port 1. Pin 1.2 refers to pin 2 of port 1, and so on. So if I want to program it independently, I have got commands for it. And what are those commands? They are set B and CLR. Set B and clear. Basically, what we intend to do, we have to either make it 0 or 1, isn't it? 0 or 1. So set B will make this pin 1. If I write set B P1.0, that means executing this instruction will make the 0 pin of port 1 equal to 1. The output of that pin will be 1 now. 1 means 5 volt. Is it 5 volt output? Okay. And when you clear that, clear pin 0 of port 1, clear P1.0, so it will make the output of that pin equal to 0 volt. Okay. Similarly, you can access any of the pin of any of the ports, 4 ports, and you can program it independently. So this is what is meant by bit addressable and bit programming. Okay, so we have byte operation also possible in 8051, as well as bit operation. Bit and byte operation both are possible in 8051. Okay. Okay, now let's look into some of the multiplexed pins of the port, and some of the pins which are multiplexed we have already discussed. The pin the port 0 pins, which are having address bus and data bus. Now let's see port 3 pins. So port 3 pins, if I take P3.0, so there is written RXD there, and then P3.1 it is written TXD. So these two pins are used for serial communication or serial communication. RXD means receive data, and TXD refers to transmit data. So these two pins, when used in serial communication, so we can use this for reading the data and this for transmitting the data. Then we have P3.2 is written as INT 0 bar, and P3.3 is INT 1 bar. So what it means? These are interrupt pins. Interrupt pins. Interrupt is a very useful feature that is available in all the microcontrollers. In every microcontroller, you will have this interrupt feature. Okay, so what happens when the 8051 is executing some program? Okay, say some instructions are written, and one by one it is being executed. Suddenly, what happens? INT 0 gets equal to 0. That means interrupt occur at pin 3.2, and say it happens when the program was executing this instruction. Some instruction was there, whatever it may be. So whenever interrupt happen, this control now moves from this point to some other vector location. Okay, what is that address location? I will tell you when we will discuss these interrupt. Some address location is there, 0008 say H. Now it start executing from whatever is written here. Okay, and then it go on executing it, that it encounters the final command end, and then it returns back to the next address. And this set of instruction, it is called interrupt and interrupt service routine. Interrupt service routine, ISR. So whenever there occurs an interrupt, the control from the main program, it moves to the service routine program. The service routine is executed, and then control moves back to the original program and then continue executing rest of the instructions. And similar is the case for INT1 also. So two interrupts can be given to 80 external hardware interrupt. These are two external hardware interrupt. So that means if I'm talking about external hardware, that means some internal software interrupt would be there. Yes, it is there. Internal software interrupt is also there, and we will talk about it in detail when we will be talking about interrupts. Okay. Uh, for that, no external signal is required for for internal software interrupt. Okay, no external signal is required. Whenever some condition in program causes some SFR to have a value, okay, of 0 or 1, okay, then interrupt service routine is serviced. Okay. One more thing, what happens if interrupt happen at both these pins simultaneously? Okay, there may be a condition in which both INT 0 and INT 1 receive the interrupt at the same time. Then we have a feature in 8051. It is called uh, priority priority uh, what we call ordering or priority setting, and int0 has got higher priority than int1. So that means if both interrupt occur at the same time, then int0 interrupt will be serviced first, and then int1 would be put in queue, and once int0 interrupt is executed, service routine is serviced, then int1 service routine is executed, and then command moves back to the main program. So this is how it happens. Now let us take uh, P3.4, where it is written T0, and P3.5, where it is written T1. So these two are timer pins. Timer pins. There are two timers. T1 external. Again, these are external timers, hardware timers, T0 and T1. I told you that timers are used for delays. There could be software delay or there could be hardware delay. Hardware delay is produced by these T0 and T1. Okay. So continuous pulses are given at T0 or T1 uh, to produce delay. So timer has got various options. Timer can be used as a counter also. Timer can be used to produce delay also. Both functions are a bit different, but they are produced by the same T0 and T1 pins. Then finally we have two more pins at P3.6, which is WR pin, WR bar, and P3.7, where we have got RD bar. Okay. Now here comes the role of control signal for external RAM. So they are used as control signals for external RAM. Okay, so write means writing to the external memory of the external RAM, and reading means reading from the external memory of the RAM. Okay. Okay, so these are some of the uh, pins that are used in 8051. Okay. Okay, I was also talking about one pin which I told I will be talking about at the last, which is PSEN, PESEN, Program Status Enable. Okay, so I told you that there is 16-bit address bus A0 to A15 and 8051, and this should allow 64 KB of external memory to be accessed. But I told you that 64 KB of external ROM and 64 KB of external RAM, total of 128 KB, can be accessed through this address bus. And since both have same address range from 000H, the memory address range 000H to FFFFH, this makes it 64 KB. This does not lead to any confusion because there are separate control signals for external RAM and external ROM. RD bar and WR bar are control signals for external RAM. Okay, while PSEN is the read signal for external ROM. I hope you understand this difference. And it would be much more clear when we will do programming. Okay, so I'm stopping the recording here.